So let's work that out on a particular example. Say I want to know the distance between something that we can map at a location, -1 and 4, and something else at a map that we can map at the point 3 and -2. And so what's the distance between those 2 points? And I hope you can see the application of this. What if these represent the city blocks in a city system, and we have one object that we can locate as at this intersection, another object that's located at that intersection? What's the distance between those two in a straight line? So how do we solve that? Well, we know what our distance formula is. So let's just use that. And we can use that distance formula because we proved it. We've solved it. So now we can use that as a tool when we want to use it. So distance equals the square root of x2 minus x1. And I can set any one of these. So I can make this my x1, y1 points, and this can be my second set of points. That's what the subscripts mean. They're just to identify different sets of points. They're not a mathematical description. They're just more of an illustrative description. So x2 minus x1. So 3 minus a 1. And remember, it's the entire minus 1 that I'm subtracting. And then I have a y2 minus y1, which is a -2 minus a 4 squared. Plugged in all my unknowns. It's just a matter of just crunching it out diligently and correctly. So distance equals 3 minus a 1 produces a 4. 4 squared is a 16. -2, take away a -4 is a -6. -6 squared is a 36. Yep, I'm just checking. -2 minus 4 is 86. And then I'm left with a square root of 52. So my distance between those 2 points is a root 52. And since I like distances and I'm kind of curious what that is, let's figure out what that is. Roughly 7.2. I'm using the squiggly equal signs there as approximation, 7.2, because the decimal goes on for quite some time. So the distance between those 2 points is roughly 7.2 units.